Hypersonic cruise pathway, from technology demo to fielded capability. Hypersonic cruise flight is less a single breakthrough and more a stack of hard problems solved in sequence. Start a supersonic combustor, keep it lit, steer precisely at Mach 5+, and manufacture the airframe at scale. India's pathway runs from demonstrators that prove physics to an operational missile that commanders can schedule on a tasking board. This is the detailed explanation of what must happen between a technology demo and a fielded hypersonic cruise capability. It begins with propulsion. A scramjet needs air compressed by speed itself, no rotating compressor. So the vehicle must be boosted to supersonic, hypersonic conditions before the engine can even try to burn. A solid rocket or liquid booster lights, accelerates, and then hands airflow to the scramjet isolator and combustor. The first milestones are ignition and stable combustion across a range of Mach numbers, angles of attack, and inlet pressures. Engineers iterate inlet geometry, fuel injection, often gaseous kerosene-based with pilot flames, flame-holding cavities, and thermal liners until the engine lights fast, stays lit through shocks and maneuvers, and shuts down safely on command. The structure must survive heat and stress. At Mach 5 to 7, skin temperatures soar, leading edges and inlets see brutal heating, and pressure loads vary with every gust and bank. That drives materials choices: high-temperature alloys, C6 composites, and active or passive cooling in hotspots. Panel joins, control surface bearings, and sensor windows need to work after minutes of thermal soak, not just seconds in a wind tunnel. Ground rigs and plasma arcs test coupons. High-enthalpy tunnel runs validate heating models. Then flight data refines the thermal map so margins are real, not guessed. Guidance, navigation, and control turn speed into accuracy. Inertial measurement units drift quickly at hypersonic timelines unless aided. Star satellite fixes help mid-course, while terrain or scene matching can refine terminal aim over land and coast. Control comes from body flaps, canards, or fluidic jet interaction in the inlet afterbody. Algorithms must reject sensor noise from shock buffet and keep the vehicle on a narrow energy band so the scramjet neither starves nor chokes. The payoff is repeatability, a vehicle that holds commanded altitude, range, and cross-range while still executing terminal maneuvers to complicate interception. Test campaigns move from clean demos to operational realism. Early flights prove boost transition, scramjet cruise, and telemetry. Next waves add guidance waypoints, bank-to-turn logic, terminal dives or cross-range jinx, and seeker windows for future variants. Range safety, ship tracks, and chase aircraft collect data. Each shot updates the combustor map, the thermal life model, and the control laws. Reliability scoring evolves from engine lit to met target window in adverse winds with margin. Warhead and effects are sized for the envelope. Hypersonic speed provides kinetic energy. A compact unitary warhead with smart fusing can finish ships, hardened nodes, or radar faces without a huge payload. For maritime targets, sea-skimming is less practical at sustained hypersonic speeds. A mid-altitude approach with a steep terminal dive balances survivability and accuracy. Overland, terrain masking at hypersonic pace is limited. Instead, altitude control, cross-range, and timing craft a flight path that avoids dense defenses and arrives from non-obvious bearings. Networking turns a fast missile into a smart one. Launch on remote from patrol aircraft, ships, or satellites provides the initial track. Mid-course updates via directional links can refine the path if the target moves. Because hypersonic windows are short, Q quality matters more than for subsonic cruise. The kill chain must deliver fresh, precise coordinates just in time, not too early. Where updates are impossible, scene match or terminal seekers, RF/IR, give last-mile assurance without broadcasting the vehicle's position. Counters exist and shape doctrine. Defenders are experimenting with wide-area infrared tracking, high-power radars at unusual elevation angles, and intersectors optimized for high closing speed endgames. The response is speed plus unpredictability. Vary altitude, bank to change heating signatures. arrive in coordinated packages with decoys and standoff shooters, and keep the launch platform outside adversary threat rings. Hypersonic cruise does not make forces invincible. It makes specific time-critical targets harder to defend when timing matters most. Industrialization is the leap from can fly to can field. Scramjet combustors and inlets must be produced with tight tolerances. Heat-resistant materials need reliable domestic supply. Canisters, boosters, and ground support must be standardized, and depot-level repair must be defined so airframes can be turned around after real thermal cycles. Software is a product. Combustor control maps, guidance laws, and seeker code need version control, cyber hardening, and rapid update pipelines as data arrives from tests. Integration with India's force structure decides value. Air launch extends reach and complicates defenses. Ship and coastal batteries provide persistent maritime pressure. Road mobile launchers put inland nodes at risk without exposing aircraft. Pairing with space-based surveillance, maritime patrol aircraft, and AEW&C creates a find-fix-finish loop fast enough to exploit hypersonic speed. Doctrine will reserve hypersonic cruise for high-value, time-sensitive targets where minutes change outcomes. Subsonic cruise and ballistic options carry the routine load. The destination is an operational weapon that commanders trust. Predictable ignition, stable cruise, accurate terminal, and sustainable production. Getting there is an engineering marathon. Propulsion, heat, control, guidance, testing, and manufacturing run in parallel with a kill chain that can feed it credible targets. For deep dives on scramjets, thermal protection, and India's roadmap from demo flights to deployable hypersonic cruise, visit globalinfoveda.com.